Welcome to my presentation called All the Cool Kids. My name is Matthias Noback. I'm proud CTO at iBuildings in the Netherlands, where we have this company packed with awesome developers. So that's just something that I want to mention to you. Not that it makes any difference, probably, but I'm really proud of that. All the Cool Kids is the title, of course, of this talk. And, well, since I have studied philosophy, I always try to define what kinds of words that I use and what they mean. So let's take a look at the meaning of cool here. And, well, you might be thinking maybe NoSQL cool. No, this might be a little bit back in time, where 5 to 6 years ago, NoSQL suddenly became sort of popular or sort of cool. And then there were different databases which, well, how do you say this, supported NoSQL, I don't know, or were NoSQL databases. And we were all like, oh, which one should we choose now? Then at some point we had Redis, which sort of counts like a NoSQL database, I guess, because it's not a MySQL database. Not sure about that. At least there at some point we created, or they created a nice list of NoSQL databases, currently more than 225 of them. And yeah, there's something about Web 2.0 needs, and I don't know. That seems from a distant past as well. I don't even know what the version of the current version of the web is these days. Anyway, then some people like Martin Fowler started to write about this phenomenon, and well, he basically explains the different types or categories of NoSQL databases. And well, I don't know. Suddenly they were less cool because we just understood what they were and what kinds we could use in our projects. So, well, at least this is what I think. You should use cool things whenever you understand them, whenever someone has written a book about them or has at least explained to you what those things are. You shouldn't just hop on this train, well, trying to use something that is cool these days. You should first understand it and then use it in your projects. Of course, but that's more or less a no-brainer. So what else is cool? I guess you were thinking about JavaScript already. Well, we are at PHP Conference, but I'm sure many of you will know JavaScript and, of course, know that it is cool, right? So at some point, you will be overwhelmed by whatever is out there currently. And, well, this slide is already outdated, of course. It's just that there are so many new things in the JavaScript world arriving to us each day. Well, I always try to use those cool things that prove to last. Well, they have to be. Well, we have to be sure that these are not just hype things that are just here for 1 week or so. So we always watch the tech monitor there and see whatever lasts for longer than that. Anyway, these things are not what this talk is about, so we can just leave that aside and take a look at what I think is really cool. Right? Take a look at that coolness. That's really awesome. These things, these technologies or techniques, they aren't really cool in a hype sense. Of course, these things become a bit of a hype because, well, many people at some point see that these are important things for us as developers. But they also have a proven track record. None of this is new or modern or like cool in this sense of, well, it just got out there this week or last week. These have a proven track record, and we are safe to use them while they are being cool. So these are exactly the kind of things that I'm looking for in my job. And, well, they may be in some way familiar to you already. So this is not really about the cool things that, well, you have to know about because, well, it's new and it's shiny. These are the things that we have to keep talking about again and again. Because, well, what I see around me is that there are some very serious psychological impediments for adopting these technologies. So first of all, you might be looking at other companies or other teams and be thinking that I want to do what they do. And somehow you feel that you can't do this. Because, well, maybe you're scared of trying something new and not being sure whether or not it will work out in your team or your project. You may also feel that you can't have all of those cool things. It may just be too much. Or, even worse, I guess, I'm doing quite well already, right? You're doing none of that stuff and feel that you're quite fine at the moment. Well, To be really honest, some of our projects may be actually too simple to do a DDD with, for example, or too small to actually thoroughly test, or too short-lived. Well, it may not be economically viable at all to do any of this. Too much time constraint. Somebody may be screaming at your desk like, finish this, finish this. Okay, so we have to overcome a bit of this anxiety and look at ways in which we can still try these things or do some of it. And of course, do the best parts of it. So yes, I think that you can do a lot of these things and not have to be scared about this. Of course, you'll get used to it. It will take some problems, some pains at the beginning. But, well, yes, of course, you will get used to it, and you will also get much better at it. And also, your projects will become much better by trying these techniques. And there are light options. You don't have to do everything that DDD tells you to do. You can just do part of it. So it comes down to listen. Well, of course, listen to me. But well, you already want to do this. That's great. And then, well, you have to get home and start reading more about this stuff. Read the books, the standard books, of which I show you the covers, if applicable. Read the standard articles, the standard blogs about this. And then just start practicing. Start doing some things in your projects that will make them better. And what's, I think, most important, will make you as a developer better and also more valuable, which makes it easier for you to go to your boss and say, I want some more money, because I'm now such a super developer. I know about DDD, BDD, microservices, CQRS, event sourcing. You know, that is worth some money, right? So I'm going to cover all of these subjects in the next 40 minutes. So please don't interrupt me. I'm just trying to give you a really quick overview of the subjects and, of course, also why you would want to dive into these things in more depth later after this talk. So we start with DDD, and this is a picture of Eric Evans, who wrote this book, Domain-Driven Design, Tackling Complexity at the Heart of Software, which is the subtitle of the book. DDD stands for Domain-Driven Design, and as you probably know, it has brought us many of these really useful tactical patterns. We know now about entities, value objects, how to distinguish them, and well, this basically gives us some structure to our code bases, our domain models. For example, entities, these are the only things basically that really change in your application. They are identifiable, well, they have an ID, of course, and they can act as the root of a bigger aggregate. Value objects, immutable objects, like basically any object should be immutable except entities themselves. Value objects describe entities, they describe aspects of it, and they encapsulate the logic or the validation for that description. Aggregates, these are basically just composites of objects, entities and value objects. But the interesting thing about aggregate is that they can be used or can be considered to be the transactional boundary. So whenever you're going to change something, you're only persisting or handling one change within that aggregate per transaction, per database transaction. Repositories, another tactical pattern, should be often seen as a collection of aggregates. So you just ask the repository, can I have the aggregate with the ID, something. And then you have domain events, which is a very interesting design pattern, so to say. These events are immutable because they represent whatever has changed in the past, in particular within one entity. Right, so that's a lot. And of course, this is really the brief summary. Dive into this again, read more about this, and your code will be better. Because, well, what changes because of all of this? Once you know the definition and the uses of these different concepts, we don't design our code with the database in mind anymore, which will make our domain model much better. We in fact design objects properly in the way that object-oriented programming, well, was supposed to work. And we don't calculate change sets anymore, just like we do with, for example, Doctrine. With Doctrine, we say, oh, here are my entities, and just calculate whatever has changed and then flush it to the database. All right, so now we only process the change that happens in our entities by, well, basically examining our domain events. But so far, much of domain-driven design looks just like better programming, like OOP as it was supposed to be. But the better things are still to be discussed here. Things like ubiquitous language and domains and contexts. So ubiquitous language is really a crucial part of DDD, and I think it's only it's the main takeaway, so to say, or the only thing that you have to keep in mind if you were to forget everything else. The ubiquitous language is the language spoken by both you as a software developer as well as any of the business people that you interact with. So now you don't have to translate anymore things that those business people tell you, the stakeholders, so to say, and what you will find in your code base. So the same words, the same language constructs, the same grammatical approaches there can be seen both in conversations with your business people as well as in your code base. So that's really interesting and also really important for improving your domain model there. Then core domain, which will be the aspect of the business domain that is distinctive. So this is a particular part of the domain that is very important to your business. And if you write good software for this, including a good software or a good domain model, that software will make a big difference for your client. So, of course, you can make them very happy about that. Core domains are separated from generic subdomains, or more in general, subdomains, where, well, it is an important part. Well, of course, the business wouldn't function without it, but you can use standard software for this, generic software, maybe buy the software or rent it or let it be developed by people who are much cheaper than you are or anything like that, because it's not really core to that business. Then bounded context, there is much confusion about that. This is just a boundary for the context, right? A context means that, or we have concepts because concepts make sense only within a certain situation, a certain context. And concepts will end, or the meaning of concepts ends at certain points. So within one bounded context, the concepts are really the same. The words will mean the same thing. Once you cross the boundary, words start becoming something else, or start to mean something else, or some words won't even be used in another context, where in this context they are being used. Bounded context can be used to separate teams. So one team can work on a particular bounded context where words make sense in a particular way, and then you have another team working on another bounded context where words have other meanings or are irrelevant to the other team. And then come the strategic patterns or strategic concepts of DDD. Well, once you know about this bounded context idea, then you can draw maps of how these bounded contexts are related to each other. And you can see or start to define the ways in which contexts are related to each other. So you can see that maybe you're, depending on other contexts, maybe you're having sort of the same domain model as other contexts do. Maybe you have to translate between domain models there. And these things are actually very useful, as at least I find that this is in practice very useful, because well, it allows you to define relationships between teams as well as code bases, and you can see where there is a mismatch between the two. So this is about discovering everything that's going on in your client's application or your application, and it will also give you some ideas about how to split up these applications. And create separate, really bounded contexts where there is an actual physical boundary between each of the contexts there. And this is also where I think, because well, it's very complicated stuff, of course, and I think this is not really something that you start with if you're learning to program, of course, but this is where basically our future is or our horizons are. We can infinitely expand our knowledge and experience here. So that's a good thing, of course, if you're looking for something to improve yourself. Discovering things about the business's domain can be done using techniques like event storming. There are other different techniques that you can use there. This is something that's very useful to learn if you're a developer and if you're working with a client. And, well, who isn't, really? The same for interviewing domain experts. This is something that we have to become much better at. I find that most developers are really not able to to really ask for the right things. So we have to learn how to communicate with the client, really understand what they're trying to achieve, really trying to understand their business domain, and make sure that our domain model solves their issues there. So a lot of DDD is really about, well, something that the DDD community calls crunching domain knowledge, but also about writing good code, growing this domain model, which is an agile way of looking at domain models, keeping or always refining that same model, and make sure that it does some very useful work for that particular client that you work for. In other words, we create software that matters, right? And as I said, as software developers, we should be cool and be part of this DDD movement. I'm not sure how much people are already doing DDD. Can I see hands? Or doing something with DDD, right? Okay, quite a lot. I guess something that you should look into and, well, get better at this. Also, if you're sort of maybe you're a client yourself, or you're a team lead or something, and you keep seeing that whenever you ask your team to create bananas, they create apples. Well, that is something that happens in real life. DDD can really help with that. So DDD is, of course, about discovery and understanding what's going on, and also about creating the right thing that the customer wants. And this easily, of course, brings us to BDD. Who does BDD? Right? Okay. More or less a different group of people, but still quite a lot. So definitely dive into that. This is Dan North, who came up with the idea. Well, of course, as a developer, we know this situation. There is a stakeholder, and he says, well, I want something. And you as a programmer say, okay, that's good, but I want to do this in an agile way, right? I want to feel free, I want to be an agile developer. Great. So we have this heuristic. Whenever we're doing something agile, we can ask ourselves, what's the next most important thing the system doesn't do, right? And then we put that down, or we write it down, or we just tell it to the developer saying, well, as a something, I want to something, so that something. And the so that is also very important, because now you know why it's so important for that stakeholder to be able to do this with the system. This is called a user story. And then you start discussing examples of that particular user story, what it would look like to implement that user story. So we have all this, well, we basically use this structure, given, when, then, and we describe the aspects of our application that will satisfy eventually that stakeholder. So these are called examples, scenarios, and in fact they are acceptance criteria. So we now know when our customer or our stakeholder will accept our application as a working example of whatever they wanted to do with it. So with BDD, we make this step of turning the scenarios into executable code, which verifies that, yes, the acceptance criteria have been met. And so BDD is about implementing an application by describing its behavior from the perspective of its stakeholders. And that will basically make sure that whatever you're going to write in code actually is what that stakeholder wants. So who doesn't want to do this? Who wants to write code that, well, the stakeholder isn't interested in, right? Looking at the development lifecycle a bit, it's like we write this failing acceptance test. We have the scenario in our computer, and then we start diving in, looking at the concepts, possibly using domain-driven design to find out which concepts have been in use. And we write some units of code, some classes there, for which we, of course, write unit tests. We make the test pass, and then so on and so on and so on, until we have a large group of classes which will together, or objects basically, which will together make sure that the acceptance test also succeeds. Right. So who does unit testing, by the way? Okay, that's great, that's great. And who would like to try acceptance testing if they don't yet do this already? Okay, sounds good. At least I brought some ideas to you. Good. So BDD is an agile methodology for creating software that matters. And in fact, that is the same thing as I said about DDD. And that is because it is closely related. It's about requirements analysis in this case, so it's a little bit more technical maybe than DDD, but it's also about ubiquitous language. So the language that you speak with your stakeholders should be in your examples, in your scenarios, and it should also be in your code. So there's no translation going on there anymore. You learn to talk with domain experts, you learn to define expected behavior, and all of this is related to acceptance criteria. So whenever you have implemented the application in this particular way, the client will be very happy with you, or client, the stakeholder, because it doesn't have to be your client, it can also be your someone else in your company, for example. The funny thing is that testing and the tools are only of secondary interest. Of course, they are great nonetheless. When we use these things, like for example, Behat, well, we will see that this is very nice to work with, but in the end, it's more about making sure that you capture the acceptance criteria, the examples, in the best way possible. Something else I wanted to mention here is modeling by example, which is sort of invented by Everett. Not sure if he's in the room, by the way. But I'm sure there will be people who know the guy. And this is sort of, this brings BDD and DDD, well, together. The idea is to design your domain model guided by these examples. And then once you start running these acceptance tests, you will clearly separate the layers within your application. So you will have your domain model, you will have your application services, and then an infrastructure layer, which sort of might remind you of hexagonal architecture, which I've spoken about quite often. In this infrastructural part of the application, we recognize code that is related to the user interface, like templates or HTML stuff, related to HTTP, message processing, the web framework, for example, Symfony, the file system, which actually touches the hard disk at some point, and a database. Now, you test your scenarios or examples against the application layer, and that will result in very fast executing tests, of course. Then you run some of your scenarios against the infrastructure layer, which will be slow, it will need an actual database, it possibly needs an actual internet connection, etc. But now you will know that more or less it's supposed to work it works as it is supposed to work. This brings us to this guy, who I've seen is in the room. Well, this is sort of the testing pyramid, and I know Kieran didn't invent the idea, of course. Like so many ideas in software, these aren't invented by someone. But I can just recommend any talk that he did about testing. You can find this on YouTube or anything. Just watch it and learn about the best way to design your test suite and to make sure that you have lots of unit tests, a nice layer of acceptance tests, which will still be very fast because they run against the application layer. And then you have UI tests or infrastructure tests, which are more or less end-to-end tests, making sure that the whole system, including its configuration, would run well. Okay, so BDD, modeling by example, very cool stuff, and also very helpful for reaching the goals set by DDD, which basically means creating software that matters. This will bring your focus a bit away from all the technicalities, like this discussion about NoSQL databases. Should we use CouchDB, or I don't know what it's called these days, MongoDB, for example. All of this low-level tech stuff is not the things that we are concerned about anymore, or at least we are concerned about them, but it's not our primary concern. So we are moving away from really low-level stuff to more high-level design stuff. And that's something that will make you, again, very valuable as a developer. So, take 5 seconds to digest all of this. So we're sort of on schedule. Ready for the next subject, CQRS and event sourcing. Yet another quite cool thing. This originates from, we have to take a step back and look at what CQS means. So it's without the R, but it's not the same idea, but without R, something like that. It's just something entirely different. but you can see some of the historical things that have been happening there. So looking at a piece of code, you can see that there will be command functions that do things but don't return anything. So command functions usually have some sort of an effect, a lasting effect on this object. And there will be query functions which return some information but don't change anything. They don't have side effects. And now comes Greg Young, and he sort of expands this concept into CQRS, which means Command Query Responsibility Segregation. And now, instead of having command or query methods within one object, we now have separate objects for command methods and query methods. Right? So there's a boundary there. So we still have the command function. It changes something inside the entity, but when we want to know what has been changed, we ask it to another object. Right? This may sound quite counterintuitive, because, well, how does the data get into that other object? In the first place, you can do something like this. So this is CQRS Lite. We have the entity which undergoes the change, and the data ends up being in a database. Right? Then on the other hand, we have the query object, also known as the read model, which takes the database from the database, or the data from the database, and exposes the query methods like it used to be, like it used to do. Well, CQRS is only very useful when you actually have some sort of a cut there, and the entity, in fact, the data of the entity is stored in a database, right? But then the data is copied to other places, like another database, maybe an entirely different system. And then at some point, that data will be used to hydrate or populate a read model object. So how can we bridge that gap? Using domain events. And those are just like the DDD domain events. Because inside the entity, whenever a change occurs in it, or when it's created or dies, we can generate events. So we have a domain event in the entity, which represents the change that has occurred to it. And then based on that domain event, we can add some projections to our system, which take the data from the event and make sure that a copy of the data ends up, well, anywhere it's supposed to end up. For example, in this one green read model. And this particular read model is just tailor-made for also for a particular view. And well, the most simple example would be data that is to be rendered in a sort of a list, which is simple. It has maybe two fields or something for each object. And then you have more or less the full version of the same object, or same object, which contains more data, more fields. And so based on the domain event, data is copied to the different read models that are out there. So for example, the yellow read model in this case. And also, maybe not even just your system is interested in these domain events. There may be external services, other applications that should be notified of this particular change in that entity. And of course, you can just send the method or send the events across the wire to some other application. So, well, when an entity is created, the event is like this. It's recorded, entity created. Then something changes, something more happens, something more. And all of this is being stored separately in what's known as the event store. So for each of the aggregates that come to life, the entities that come to life, we track all of the events that happen to it, all of the changes that happen to it, and we store all of that inside of an event stream in the event store. And now what we can do with this is we can replay anything that has happened in the past. We can just take the events, put them in order, and replay any of them. And, well, maybe just start creating new read models, if necessary, for our application. Maybe we have defined a new feature which requires a new type of read model. But we can also generate reports based on anything that has happened in the past, like starting at the point where we started saving those events. And we can also do some analytical stuff with it. We can do aggregations on whatever has happened in the past, and we can make even predictions based on those things. And this is, of course, an example of the true power of CQRS, where in a traditional sense, if you look at the database using, for example, PHP MyAdmin, you just open the page, you look at the tables, what's in there, and it's just what is in the database right now. and there's no way to find out what was in the database yesterday. Of course, unless you have backups, but well, that's not really a good way to find out what has happened in the past, of course. And well, with events and event sourcing, it's just like you can go back at any point in time, to any point in time, and analyze what's going on at that moment. And you can do really nice things like visualize event streams, like Jeff Klaas does. He had a nice article about this. And it's just an example of what else you can do with those event streams stored in the event store. I think it makes a lot of sense to look into CQRS and event sourcing because, well, and this is the main selling point for CQRS. It will enable you to optimize both sides of your application. The write side, which takes commands and changes things, and the read side, which returns information to any interested client, because your read models are optimized for a particular view. So usually, those read models don't have to be created in very complex ways using all kinds of difficult select queries or joins or anything like that. It's just the data that you need right there. And all the aggregations have already been done. So it's more or less like select all from this table, and you just send it to a template, or for example. But also, if you use CQRS and event sourcing, you will have all the ways to create interesting reports and analytics and, of course, predictions for your stakeholders, clients. So, again, you will become a much more valuable developer. This fits very well with DDD, which is why now we have DDD linked to BDD and also CQRS and event sourcing. So, well, you could just consider doing all of this at the same time. Well, I don't know. You could also just pick one and start learning it that way. But, well, this CQRS and event sourcing thing makes your application ready for the next challenge, which is microservices. So something that is cool and sort of popular, but also a bit hyped. And you know, there are so many things about this that there are so many jokes on Twitter, like would you be able to create microservices if you can't even create a nice monolith? Sam Newman isn't the inventor of microservices, but he has a nice book about it, and I think it's really worth a read. So yes, I mentioned the monolith already. It looks like this. It's red, and that is a bad sign. We could do something like this. Better. This is better. Now we have split the application, or the monolith, into multiple smaller services, which should do the same things as the monolith did. Or, well, as some companies do, or some teams do, they create even more microservices and link them together. So this concept of a microservice, who's familiar with it anyway? Okay, well, still quite a lot. Who actually uses microservices in production environments, so to say? Okay, still quite nice, yeah. So microservices, they undergo change as well as the monolith application does. So it accepts commands. And it emits events, possibly, because, well, whenever a command ends up being processed by an entity, this change results in a domain event, right? So we want to communicate what has happened within the boundaries of our microservice. But we might also issue new commands and send them to other microservices. Instead of responding to commands, we could also take events from some sort of a queue, for example, and, well, in fact, make our microservice loosely coupled, because now we only need to take events from a queue and respond to that instead of sending commands directly to other services. A microservice can have decentralized data. It can have its own database, or it can have no database at all. That's just up to you. And it also means that microservices don't all grab data from the same database, like we used to do. Of course, this happens a lot nowadays. But, well, at least this allows you to have some degree of separation. And it will ease, of course, maintenance, where if you want to change something in a database schema, for example, not every other piece of the system will crash because of that. Microservices are, in general, service-oriented, so they accept commands usually. Maybe they have just a RESTful API and they accept POST or PUT commands, for example. They possibly accept queries, where you can have just some GET requests, send it to them, and they will return some information to you. They are event-driven, ideally so. So of course, you can just send commands to them and accept them or expect them to make the requested change. But it's also very nice if they just respond to events, because it will make them more resilient, so to say. And you could try to design your microservice in such a way that its domain model fits within one bounded context. That might be a good idea. You could also have smaller microservices. You can also have bigger microservices. It doesn't really matter. I think this is also some matter of discussion. I'm not sure how many people actually did this successfully, so it's just an idea, which makes sense to my brain, but, well, who knows. What's interesting about microservices is that these are replaceable, so just like that. You can use different technologies, different data stores, different languages even though in practice that is not really that useful, because then now you have to have developers who are able to understand different languages in more or less the same level. So there are some difficulties there, but also some really useful aspects to it. Done right, I would say that microservices at least have to be resilient. Whenever something goes wrong, at some point in the landscape, or at some place in that landscape of applications or microservices, your microservice has to survive that crash. You have to make them redundant, so that takes a little bit of design from your actual application architecture. You have to be able to separately deploy them, so that if you deploy one microservice, it doesn't take down all the others. And of course, you have to make them decoupled, so you can work on them in separate teams and at separate moments. In reality, they need more monitoring, usually than a monolith does. And you will likely need more automation. So whenever you're deploying one monolith application, that's a lot of work usually, but it can be quite easy if you have the right scripts for that. Once you have to deploy hundreds of services, then it will be much harder, and you just have to work on your automation stuff. Okay, so I think most importantly, it should fit within your organization. In my experience, it is a great fit if there are multiple teams, multiple people who don't want to be bothered continuously by each other's problems. So with microservices, people can develop separately, maybe just now and then discuss with each other, but in general, they are able to work separately on code bases. And well, it's also interesting because there will be different ways of cooperating. And using the DDD context mapping strategy, then you can make a map of whatever is going on in your landscape of services and see if you should change something there. It will make explicit whatever is going on, communication-wise between teams, and it's just like that will be reflected in the way that you design your microservices. Also, this offers scaling options. So if you want to grow as a company and you're still working on one big project, then this is definitely the way to go. You just have to split up the one big project and make sure that teams can work on the big project while not walking in each other's way. So I would say, yes, ignore all those jokes and take this thing seriously. It's a cool thing, but it's also something that you have to learn about, read about, in particular that book on microservices by Sam Newman. It will give you some ideas, and even though you might not want to actually do microservices in your organization, it will give you some good ideas about how to design your application. So, the finale. Okay, so the cool kids. Who are they actually? I don't know, who here has a Google Friday? Yeah, okay, so of course, Stefan, you have a Google Friday. All your days are Google days, right? Well, okay, so who does continuous deployment? Oh, okay, that's great. Yeah, yeah, so you're definitely cool kids, right? Well, it turns out that all of you are basically cool kids. Yes, yes, you and you and you. That's really awesome. Well, in the end, even though I think all of these subjects that I discussed are very important to every one of you, you already know more than you think. In reality, it turns out that you know so many things that other people don't know about yet. So you are, of course, already doing special things, and things that your neighbor might envy you for. So yes, of course, you're beautiful. You're just like flowers. But well, why am I saying this to you? I think it's very important to share what you're doing, right? And of course, you're used to do this because you're at a conference. But make sure that you always tell people about what you do. And well, for some subjects, other people might learn from you. And of course, the other way around, it's the same. So you can learn from others if they share. So if you feel that in your team, in your company, this isn't really happening, try introduce some of these sharing concepts. Like make sure that whenever you have a problem, at least tell other people about it. When you have fixed something in a very interesting way, tell the other people around you about this. And you know, maybe at some point there will be like a tipping point where other people start following your example in that matter. And of course, you can also formalize this by something known as the brown bag lunches, where you just take some subject and make a nice presentation about it while others are eating. And the sound of eating just feels like people are very happy and eager to learn about this. So that works really well. Anyway, push yourself to the limit and learn about all of these cool stuff that may seem hard, but these things are here to stay. And if you want to improve yourself as a software developer, make sure you know what this is and find some takeaways if you don't even fully embrace any of this. But, and this is, of course, the way that I look at programming these days, you have to abstract the fashionable details. So whatever is hyped or is cool at this moment, just ignore that and try to find the big things in software development history. Yeah, okay, so we are at the end, and just in time, I guess, for some questions as well. At least one thing that I wanted to point you to is the joined in page. I couldn't say goodbye to the old URL style join.in/ and then a number. So this is a legacy link. I hope I don't offend anybody from the joined in group of contributors. At least thank you if you're just walking out right now for listening, and otherwise we will have time for some questions. Okay. No questions. Thank you. Thank you. But there is time for some questions, so. No questions. Okay, that's great. The slides can be found on the joined in page, and there I will have some links to recommended reading if you want to learn more. And I will be around for some time, so ask me any questions you like. Okay, thanks again. Enjoy.